All right, for the third and final lesson on sine and cosine graphs, we're now looking at like the real life applications of these functions. So we're just going to look at a couple examples. I'm going to talk you through a few of the ones that you're seeing here within our old textbook. We're not going to do written out formal notes for these. We're going to just talk through a few examples and show you some things on the calculator that you can take advantage of. So for the first one, you can see the example in front of us here. So they're using a sine function to represent an amount of water supply during some summer months. It's always important to kind of look within the problem that what things represent. So like in this case, they tell you that T represents the number of days from the start of summer. So typically a 90-day summer, which is why they set the domain from 0 to 90. And then the y coordinate, or the d of t, represents the demand, so during those summer days. So a couple things they ask us to do with this one. The first one is a sketch, and that's something that we've already been working on, is just sketching sine graphs. That was done in lesson 1. So we're going to do a sketch, and then they also are asking about minimum and maximum amounts within the graph for the function. So as far as the sketch, we could always sketch these by hand. So you can always just kind of stick with the basics of doing a sine function. Go through the steps that we've already covered in lesson 1. For example, I know that right here I have a vertical shift of 120, which is where you'd be making your first mark on the graph at 120. I can see the amplitude is 60. Also, the b value is 2, so if I did 360 divided by 2, I can see the full period is 180. Like we did before, I would break that up into 4 equal parts, which would tell me that every 45 degrees I should be making a mark. So with a basic sine graph, just with those simple numbers, I know that I would be starting at my vertical shift of 120, and every 45 degrees I'm going to make a mark. So on my first mark, I'm going up 60 units, right, from the midline. The midline was at 120. At the next 45 degrees, which would be 90, I would be going back to the midline, which puts me back at 120. And then the next 45 degrees, I would go down 60 to make my next mark, so on and so on. So you can take those steps, but of course we can take advantage of the calculator too. And we always want to consider the given domain. So these graphs do go on forever, so somewhere in there's going to be a limit to what your graph, where it goes. So in this case, we're only going from 0 to 90, so you can see it, the one that we're going to do on the calculator in a second, it's basically half of a period. So as we did this graph, we really would have only made 3 marks on the graph. The initial point, we use the amplitude to go 45 degrees, and then we go back to the midline. But at this point, when we go back to the midline, we're at the end of the domain at 90. So this graph would continue on, right? From here, the next one, we would go down 60 to right here, so we'd be at 60 for the next 45 degrees, and then we would go back to the midline. But that would be more than what's in this given domain. So we got to limit it to what we see right here. So anyway, if we're going to do a sketch on the graph, so a little reminder on the calculator for doing these. So for this one, if we go back into our y equals, so I already typed in the function here that you're seeing. So I'm trying to get the glare off. So we already typed in the function. I'm going to go to the window and get some proper window settings. So if I go to the window, so in this one, remember it said only go from 0 to 90. That was the given domain. So that's all I'm going to see on my calculator. As far as the min and the max, this is where you really need some basic understanding of the numbers that we saw. If you're looking at the function, right, we can tell based on the 120 that the center, or the midline of this graph, is at 120. Well, based on the amplitude of 60, I know that this graph from the center, if it's going to go up 60, then my highest point is 180. And if it's going to go down 60 from the midline, then my lowest point would be 60. So right there, I'm kind of seeing my lowest and my highest points possible on this graph. So as I go to my window, so for the y minimum, I know it could go as low as 60. So I'll set that at 60. And then I said it can go as high as 180. So I'm going to set that as my y max. So now when I graph, I should see all of the graph within the given domain from 0 to 90. So that graph that you're seeing right there is the same one that we were seeing on their sketch of the book a second ago. So that would be our sketch of the graph. Of course, we'd label some axis values for the x and y axis just to show some accuracy. As far as getting the maximum and the minimum points, well, for within this given domain, the highest point was the 180 that we went up to right here. Because remember, the midline was at 120. We used the amplitude from there to go up 60, and that put us at 180. So that's the highest point. And then as we traveled back to the midline, we're back to 120. And within this domain, that's the lowest point on this graph, is the 120. If the period continued, as it would if we move beyond 90 degrees, we would have a lower point at 60. But because we're only sticking to the given domain from 0 to 90, 120 is the lowest point within that domain. And so that's all we're going to get out of that graph. So one of the big things I wanted to point out on that one is because these graphs go on forever, you always have to consider the answer within the given domain that we're told. So we had to limit our responses to only responses from 0 to 90 within that domain. So that's important. The other thing that you're going to see, and you're going to see this on the next one as well, is always understand the relationship between these two numbers, right? We know this is the midline of the graph, the vertical shift. It's the center of the graph. So everything is based on that number. If we use the amplitude, that tells us how far above the midline and how far below the midline we go from there. So that's why I said I knew the highest I could go was 180 and the lowest I could go is 60. So I'm basically adding and subtracting those numbers to get the high and the low of that graph, or the max and the min. So we're going to look at one more example here. So this one gave us another sine function. So again, I want you to pull out a couple ideas within this guy right away. So this one represents a tide function, where t represents hours. So keep in mind, if this represents tide, this 4.5 is the midline of the graph. It's the vertical shift. So that's the center of the graph. So how high can the graph go? How high can the tide go? So if that's the center and it can go with this amplitude of 2.5, right? If I add those together, that tells me the maximum amount on this graph is 7 if I add those up. So that's the highest. 7 meters would be the highest this tide could go. And if we said what's the minimum or the lowest it could go, well, remember this is the center. So from the center, if I go down 2.5, then at 2 meters, I would be at the minimum. So that would be the lowest point on that graph. So there's a couple things, and they ask those types of questions. So it's always good to recognize the connection between the C value and the A value of that graph. To copy and complete the table below, this is something we could either just plug in the numbers. I could take turns plugging in a 0, a 4, an 8, right? And you could do that for all those, but obviously we could take advantage of our calculator too and just get numbers right off of that. So I'm going to pause here for a second. I'm going to graph that, and then we'll continue on from there. Okay, so keep a couple things in mind here. So I'm throwing this into the calculator. When I go to set my window, I'm always kind of considering, what window settings should I use. So in this one, based on this, I want my x's to go from 0 to 24. So it's basically one full day, a 24-hour day. So that's what's going to be my x's. And for the y's, for the minimum and maximum, remember what we just talked about. If I add those together, I get the max. If I subtract them, I get the min. So between 7 and 2 are kind of the range of the graph. So as I put that onto the calculator, so there's the function right there. So if I go to the window, again, this is a 24-hour period. And so the lowest we said was 2. The highest was 7. And so I'm going to use those as my window settings for this function. So it looks like we're getting 2 full periods of this graph. So if I wanted to complete the table with some real values, you can always just go to the table of your calculator. So second table, and I can get all those numbers right off of here. So you can scroll up and down forever on this screen and get any number that you want. So these are the numbers I could just pull right off of this to fill into their chart. If you ever just want something specific, maybe it's a number that you're not seeing here, maybe it's 1.5 or whatever, you just go to the graph and you just go to Calc and go to choose value, and that lets you plug in any X value you want. So let me go back to their problem for just a second. So in this case, if they want just specifically just 3 hours, I could go to my table of my calculator and look that up, or I just go to calculate and then choose value and plug in a 3. For something like 7.5, I kind of have to use the value option because I'm not going to see 0.5s on my table. I could set it up for that, but it's just not right now set up for that. So if I want to plug in the 7.5, so I just go to, so again, we're right here at the graph. I went into Calc, choose value, and just hit 7.5, enter. And there you go. You can see the Y value is 2.73. And so that's the easiest way to just plug in numbers like that. So here's the other one that's super key on this. For these first few parts, we were plugging in values for t. T represented time, and so we were subbing in hours for that. But look at part D. This one now says find the time. So now we're solving for t when the height, the Y value, is 6.5. So now in this case, they're giving us a Y value, and we're solving a trig equation for X. So there's two ways to do this. You can do this by hand. I could put my 6.5 right there and just start solving. You could subtract 4.5, divide the 2.5 over, do the inverse sign of that value, and then divide it by 30, and that would give you your answer for t. And that works, but we really don't get into a lot of solving trig equations in this course, so if you don't remember your trig steps on doing that, let me just show you the easy calculator way of doing this. So find all the times when the height is 6.5, so if I go to the calculator, I'm going to go back into my y equals, and in this case I'm just going to graph a separate graph for y equals 6.5. I'm going to hit graph. So you can see there are 4 points of intersection. So there are 4 times within a 24-hour period where the height was 6.5. So this is where you just read the question carefully. If it said find all the times, then you got to come up with all 4 points. If it said find the first time, well, then you would just identify the first time that occurred, which is right there, that first point of intersection. Or it could say find the last time, or the first 2 times, or however it's worded. So just read careful for what the directions are asking you for. If you want to find any of those, you just go under Calc and choose intersect. So let's just say we wanted to find the first time that it reached a height of 6.5. So if I go under Calc and choose intersect, and then you just put your cursor closest to the point of intersection that you want. So I'm going to put it right about there, and you just hit enter, 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 and there you go. So yeah, so we can see that at the first time the height was 6.5, the time was 1.77 hours. So that's, if you wanted more, like if it said find the second time that it reached a height of 6.5, you just go back under Calc and choose intersect again, and just put your cursor on that spot and hit enter, 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 and you'll get the second time that occurs. So that's the easiest way to do like the y equals question. So when they give you a y value, just graph it as a separate graph and then just calculate points of intersection. That's going to be the easiest way to approach those, probably rather than having to solve the trig equation using kind of your old trig methods. So anyway, so those are the kind of the key type of questions that we're now dealing with. So a little more with the calculator in our last section here, so know how to use those. You get some pretty basic questions on these, like what's the amplitude, what's the period, horizontal, vertical shifts, all that kind of stuff. So they can ask you to plug in for X, they can ask you to plug in for Y. So on these guys, it's just going to be important to just make sure you understand how to use a calculator when needed. Some of the basic ones, you really shouldn't need a calculator for. Here's just a couple simple ones. So like in this sine function right here where it says what's the initial population, well, I mean, that just means we plug in a 0 for p to get the initial population. So for this one, I mean, we could really use just some logic here to answer the question. Remember, if you think about a sine graph, right? A sine graph starts on the midline. So this has a midline of 3. So that's where its starting point would be. So in this case, I know that the initial population is 3,000. This is in thousands. So 3,000 would be the initial population. What is the largest and smallest? Well, remember the relationship between those two numbers. From the center at 3,000, it's going to use this to go up and down from there. So it's going to go up 2,000, and it's going to go down 2,000. So it's going to increase to 5,000 if I add those together. And it's going to go as low as 1,000 if I subtract those. And so those are just some pretty basic answers we can get without a calculator. But when does the population first reach 4,000? So this is where you would say, okay, let's graph us two equations, y equals 4 and y equals this guy, and find out the first time, based on that word, the first time where those two graphs intersect. So that would be the easiest way for answering that one.